Alright, before we start, let's look at the scheme of work. So currently we are in week 11, right? Week 11, supposedly we should cover one-way analysis of variance, but we are already advanced, right? Kita dah habis cover test of independence last class. So this week kita dah habis chapter number 4, right? So next week we will go to chapter number 5. So once we finish chapter number 5, we're going to have test number 1, means that assessment number 3, right? Assessment number 3, test number 1, assessment number 2, right? So assessment number 2, test 1 will cover chapter 4 and 5. Right, so make sure you do all the revision on chapter number 4 and chapter number 5, right? Chapter number 5 means minggu depan baru kita tengok lah. Okay, so as a reminder, group project you should submit before 1st July, right? Before 1st July. So kejap lagi I akan buka Google Classroom, right, untuk submission Google group project, right? Ada soalan tak berkenaan dengan group project? So if you don't have any question, let's start with our final subtopic for chapter number 4. Right, for chapter number 4, last subtopic, which is one-way analysis of variance. In short form, we call as Anova. Anova, one-way Anova is used to determine whether there is any significant difference between mean of two or more independent group. So if you still remember in hypothesis testing for independent group, right, means that one independent sample t-test, right? For independent sample t-test, remember independent sample t-test kita ada dua group, right? Group 1 and group A and group B. So we want to know whether there is a significant difference between the mean of group A and mean of group B. So we will use T distribution, right? Alpha divided by 2 or alpha with degree of freedom, right? So this is for independent t-test, right? So independent simple t-test, we compare only two group, the mean of two group, right? So one-way analysis of variance, if you have more than two group, let's say you have group A, group B, group C, group D, right? More than two groups, so you want to know whether a mean of group A, B, and C and D ada different tak? Ada perbezaan tak? So it's actually an extension from independent sample t-test lah. So we're going to use one-way analysis of variance. So the distribution that we're going to use is F distribution lah. Right? Instead of using T distribution, we're going to use F distribution. Right? So dekat sini dia kata if the mean are significantly different, that we can say that, so if you have found that there is a significant difference, we can say that the variable had an effect on the variable being measured, means that there is at least one group is different, right? So for example, a career office is study the difference in starting salaries, which is our dependent variable, in different measures, right? So the factor is academic field such as computer science, engineering, and education. So if you can see here, we have three groups. So before we go further, let's look at the requirement for independent sample t-test. So requirement for independent sample t-test, let's refresh back our knowledge. So it should have one dependent variable, another one one dependent variable and one independent variable. So one dependent variable ni should be numeric, right, ataupun quantitative, and independent variable should be categorical. So categorical with two level, level A and B. So this is the requirement for independent sample t-test. Sekejap, selalu besar. So requirement for one-way analysis of variance, right? Requirement, right? So sama juga dengan independent sample t-test. We should have one dependent variable, another one independent variable. So dependent variable should be numeric or quantitative, right? And the independent variable should be categorical. But it should have more than two groups. It means that group A, B, C, D, E, F, and masih ada banyak group lah. So we want to compare. So basically, the concept are same, right? But one-way Anova or one-way analysis of variance is an extension from independent sample t-test. It assumes each group are independent lah. Right, sama juga. Group A and group B for independent sample t-test should be independent. And for one-way ANOVA, group A, B, and C should be also independent. Right? So the assumption for one-way ANOVA also same as independent sample t-test. Right? First assumption is a normality, means that the sample obtained from the population must be normally distributed. Means that group A should show a normal distribution, normally distributed. Group B also should be normally distributed. Group C also normally distributed. Same goes to independent sample t-test lah, sama juga. Dia mesti group A mesti normally distributed, group B also normally distributed. Right? So for second assumption is we should check for constant variance lah. Means that each group should have a same variance lah. So variance for group A should equal to variance for group B and variance for group C. Mesti sama. And the third assumption is it should the sample drawn from the different population are random and independent lah. Means that group A are not related to group B. Group B also not related to group C. Mesti independent each other lah. Okay. Alright. So example for one-way ANOVA. So let's say you have treatment level, means that the group lah, group 1 until group K. So each group you have value observation lah. This is should be numeric lah. So this one is a numeric. Observation should be numeric lah. Means quantitative variable. So this group 1, right? For group 1, value for group 1 kita panggil Y1, Y12, until Y1n. Right? So the total for the total observation value dalam observation ni total should be Y1 dot. Right? And the average Y bar 1 dot. So the total of the total, maksudnya you measure the total for each group. Maksud group 1 you dapat total 1, group 2 you dapat total number 2, until group K you dapat total number K. So the total of the total is Y dot dot. Right? So the symbol lah, I just want you to familiarize with the symbol. So let's say, I ulang balik let's say this is your data, right? So you collect data, let's say I make it example, CGPA of a student STA 404, group A, group B, group C, for example. Let's say kita ada group A, group B, and C lah. So saya letak macam ni. So this is CGPA kan, this is group A, group B, and group C. So you ada 3.2, 3.5, 2.0 and so on lah. Let's say this one 3.1, 3.5, 3.6. This is 4.0, 1.89, 2.50. So let's say you ada 3 group, you collect a data for 3 group, right? So let's say ada banyak lah, sampai 10 lah. Let's say 3.10, this one ada banyak lagi. 4.0, this is 2.5 for example. So dekat sini, this one kita kata Y1, 1. This is Y2, 1. This is Y3, 1. Right? So this is the symbol that we use. So the total, let's say the total of all observation dekat sini, kita panggil Y1 dot. This is Y2 dot. This is Y3 dot. Right? Just a symbol for calculation. So the total of the total, maksudnya total kat sini, this is the grand total, this is Y dot dot. So Y dot dot represent the total of the total. Okay, nanti kita akan tengok how to calculate one-way ANOVA. It's a bit complicated compared to independent sample t-test because we have more than 2 groups. So the total variation in the data is measured by total sum of square lah. Kita tengok bawah. This is the one-way ANOVA table. So from the original data, this is the original data, right? Original data. So we should have more than 2 groups, right? Let's say groups D ada banyak pun boleh, tak ada masalah. So then from this original data, we need to transform this data to one-way ANOVA table. We need to transform this data to one-way ANOVA table. So this is the structure, layout or presentation for one-way ANOVA. So this is one-way ANOVA table. So in the first row, we have between treatment. So this is the source of variation. Nama pun dia akan sama, the source of variation. We have sum of square. We have degree of freedom. We have mean square. And last we have the distribution lah, the value, which is F distribution. So the first row should contain between treatment. The second row should contain error. The last row should contain total. So this is what we call dekat sini bila kita dapatkan sum of treatment the first row ni, kita tengok the first row, right? So for sum of square, kita panggil sum of square treatment. So kita nak calculate for the second column ni, sum of square error. This is sum of square total. So the formula for sum of square treatment is Y1 dot square minus Y dot dot square divided by capital N. Right? So Y1 dot means that, remember, dot means this is the observation lah, right? Y11, Y12, Y13 and so on lah. This one Y22, Y23 and so on lah. So kita akan ambil Y1 dot square, maksudnya dekat sini the value is 3.2 square plus 3.5 square plus 2.0 square plus until the first row habis, the first group habis, until 3.10 square. And then we need to plus for everything lah. 3.1 square plus until 4.0 square sampai habis hujung ni. And then plus lagi sampai daripada sini ke sini lah. Right? So nanti kita akan tengok example. Just want to understand the formula and the basic structure. So Y dot dot means that the total here lah. Kita akan ambil total kat sini and then we square. Sama juga dekat sini, Y dekat sum of square total, right? Yi j square. It means that the total for this one, right? This is what we call Yi j. Maksudnya Y 1 1 for the total. This is for total 1 dot, right? So kita akan ambil the total y1 dot dekat sini, square sampai habis lah. Kita tengok example nanti ya. So the sum of square error, it means that the sum of square total minus sum of square treatment lah. Maksudnya this one minus this one. So you akan dapat the sum of square error lah. So the degree of freedom means k minus 1. K is number of group, right? So let's say you have 3 group here. So 3 minus 1. Right, so N, capital N is the total observation lah. So ada berapa observation you ada minus dengan number of group. So the sum of square total is number of observation minus 1. And then the second last column we have mean square. Mean square column. So in mean square column we only have 2 value dekat sini. So first one is mean square treatment. Another one is mean square error. So we don't have mean square total. We only have 2 value, mean square treatment and mean square error. So mean square treatment is the sum of square divided by degree of freedom. Sama juga dengan error. Sum of square divided by degree of freedom. So the ultimate value that we want to find is the F value, the F distribution. The F distribution, we take a mean square treatment divided by mean square error. So in F distribution is a bit different with the T distribution. So remember T distribution, we only have alpha divided by 2 and 1 degree of freedom. But for F distribution, we have alpha, degree of freedom 1 and degree of freedom 2. So remember we divide these 2 value, right? Mean square total treatment divided by mean square error. So mean square treatment we have their own degree of freedom. Mean square error pun ada their own degree of freedom. So we need to divide by, we need to consider these 2 degree of freedom lah. So degree of freedom number 1 is mean square degree of freedom for treatment. Degree of freedom number 2 should be degree of freedom for error. Right? Okay. So hope you understand the concept lah. So let's look at the hypothesis testing format. Benda yang sama aja macam sebelum ni kita buat. But the null hypothesis, right? So remember I compare dengan independent sample t-test because this is closely related lah. Because one independent sample t-test we compare only 2 group. For one-way Anova, we compare more than 2 group. Benda yang sama, but the concept should be also same lah. So the null hypothesis, we want to know there is no difference between mean group A, group 2, group 3 until group K lah. So mu1 equal to mu2 equal to mu3 until mu K. But for the alternative hypothesis, right? So the alternative hypothesis always same. At least one pair of mean is differ, right? So sekurang-kurangnya satu mean differ. Dia tak semestinya semua kena differ. There at least one. Let's say group 1 equal to group 2. But group 3 is not equal to group 2 and group 1. So at least one mean differ. Then we're going to reject null hypothesis. So the significant level, the next step kita kena specify significant level. Then the test statistics is F distribution, mean square treatment divided by mean square error. If you are using p-value, dalam final exam dia bagi p-value, kita guna p-value lah. P-value dia punya decision rule sama saja. If p-value less than alpha, null hypothesis is rejected. That is the simple rule for p-value, always same. But for critical region, right, sama juga step sebelum ni, kita kena cari critical value and then we highlight the rejection region. If the F calculated, this is the F calculated, lies under rejection region, then F null hypothesis is rejected. Okay, so we can conclude based on the accepted hypothesis lah. As if you accept null hypothesis, we conclude based on null hypothesis. If you reject null hypothesis, we conclude based on alternative hypothesis. Okay, then kalau kita tengok dekat sini, the hypothesis says that the null alternative hypothesis says that at least one pair differ. Maksudnya, let's say we have group A, B and C. So, conclusion, kita accept null alternative hypothesis. So, dalam alternative hypothesis, it says that at least one pair different. Right? So, which pair is different, dia tak bagi tahu. Right? Dia bagi tahu kat kita, information yang dia bagi dalam one-way Anova ni, at least one pair different. So, which pair is different, we don't know. So, the next step is we need to do a multiple comparison test. Name as post hoc test lah. So, if we only do multiple comparison tests if we accept alternative hypothesis. If we accept null hypothesis, we no need to do multiple comparison tests because they are all group are equal kan, tak perlu buat comparison test lah. Kalau kita accept alternative hypothesis, then we need to do multiple comparison test or post hoc test. So in post hoc test, it will do basically independent sample t-test with the correction, right? Such as Bonferroni correction ke, Tukey correction ke, Fisher least significant ke. So di kita ada banyak method. So kita ada Tukey test, Fisher least significant or LSD, least significant difference, ataupun kita ada Bonferroni method. Ada banyak lah, dalam SPS ada banyak. So now let's look at example number 37. So basically this last topic ni semua example I dah bagi dekat you tau. Just matter of explanation saja. So for you to understand. So kalau kita tengok example number 37, right? Example number 37, tensile strength of cement is being studied. 4 different mixing technique can be used economically. A completely randomized experiment was conducted and the following data collected. So we have mixing technique, dia ada 4 mixing techniques. Right? Each mixing techniques ni, dia ada, they collect the data of tensile strength lah. So they collect 4 observation. Right? To understand, they collect, for the first mixing technique, they collect 4 observation. 4 observation ni mesti numeric lah. This is a categorical. Mixing technique is a categorical. So for missing technique number 2, they also collect 4 observation missing tensile strength, sama juga 3 and 4. So once you already have the observation, so this is our data, yang highlight green, This is what we call Y11, Y12, Y13, Y14. This is Y21, this is Y31, this is Y41. Sama juga, dia akan pergi ke kanan bersama. Y22, Y23, Y24, Y31, Y32, Y33, Y34. Right? So this is the Y dot. Right, means that the total of the first row. Remember, in programming pun sama jugalah. Dalam data frame, right? If you are using Python, so if the first value here, right, is representing row, the second value here representing column. Right, benda yang sama kan dalam programming, kita guna dalam matematik pun sama juga. The first one is representing row. Row dot means that one dot means that the total of the first column, the first row, the first group, right? This is Y2 dot and so on. This is Y dot means that the total of all observation. Y dot means the total of observation. So this is the average. So now let's look at one-way Anova table. So the one-way Anova table is a standard table. So we have source of variation, right? The second one is we're going to have sum of square, and the next column, next column we have degree of freedom, and the next column we're going to have mean square, right? And the last column we have f value. So the first row we're going to have treatment. The second row we're going to have error, and the last row we have total. This is a standard table for one-way Anova, right? So dalam final exam on test, upcoming test, so you kena remember the layout of one-way Anova. So the first value dekat sini, in the first cell ni, right? The formula is sum of square treatment. So y I dot square minus y dot square divided by capital N, and this one should be divided by n, right? Sekejap, sama tak formula dia? Yup. So dekat sini y I dot means that this is y 1 dot, this is y 2 dot, y 3 dot, y 4 dot, means that the total for each group, means that the first one 11,884 square divided by so this one divided by 4, right? Tapi benda yang sama lah, divided by 4 plus 12,625 square divided by 4 plus 11,735 square divided by 4 plus 10,665 square divided by 4. So this is the first equation tu, the first term in the equation. Means that we need to sum all the y I dot square divided by n. So n ni mana dapat? So we have 4 observation kan kat sini. So 1, 2, 3, 4. So we divide by 4. So minus with y dot square. Minus y dot square means that the total of all observation. The total of all observation. Semua dalam ni ada 46,909 square divided by berapa observation kita ada? 1, 2, 3, 4 multiply with 4, 16. Right? So the total here, you calculate, you should have 648.437. You calculate balik, takut salah kan? 643,648.64 437. You gonna calculate balik. I'm not sure whether this is a right calculation or wrong calculation. Right. So the next one, degree of freedom. Degree of freedom is k minus 1. K minus 1. K is the number of group. Right. So you ada 4 group minus 1. So you akan dapat 3. So this is the first one. The second one, and the third one is mean square. Mean square treatment means that the sum of square divided by degree of freedom. So 64,000. So 643,648.437 divided by 3. So you will get 2,143 549.479. Kenapa dia macam salah? Let's look at I salah ambil value dekat sini. This is not the correct one kan? Supposedly this one, right? So you tengok berhati-hati. You kena kira betul-betul. That's why I pakai ambil saja. Right? So you kena kira betul-betul. So this one should be 4. This one 489,740.237. You kena kira balik ah. I tak kira kan? I just nak tulis value saja. This is 489,740.237. And this is 3. So divide by 3 lah. So 489,740.237 divided by 3. So it should be equal to 163,246.7457. So, okay. Right. So this is how we calculate the first row for one-way Anova. Then kita akan leave error dulu, right? Sebab error is a bit complicated to calculate. So we go to total, SS total. SS total should be summation of double summation of Yij square minus y dot dot square divided by capital N. So double summation means that we want to total all the observation dalam ni lah. So means that 3129 square, right, kita ambil the first observation, plus 3000 square plus for the first row ni 2890 square. And then we continue for the second row, 3200 square plus until 3150 square. And then kita continue sampai hujung lah, 2765 square. Right? Okay? Boleh eh? So this is the first term yang kita calculate. This is the first term. Right, means that kita nak tambah semua observation with the square. Bukan square kat luar, means setiap satu observation mesti square. You need to remember this because our final test next week. So next, we should minus with the y dot dot. Y dot dot means that the total of all observation is 46909 square divided by 16. Right? So supposedly you akan dapat this one lah. 643,648.437. So you letak kat bawah ni. 643,648.437. Right? So the degree of freedom for some total is n minus 1, right? N minus 1. So n minus 1 sepatutnya kita akan dapat ada berapa n semua ni? Dah ada 16 kan? 16 tolak 1, 15. Right? So dekat sini dia tak ada mean square total, tak ada. Right? Remember that. So we only have mean square error and mean square error and mean square treatment. So for error dekat sini, just tolak lah. Total tolak dengan treatment. So you akan dapat mean square error. So 643648.437 minus 489740.237. So you should get 153908.2. Is it? Tengok sama lah. And then dekat sini sepatutnya N, capital N minus K, right? So you should remember the formula, right? So kadang-kadang I tak bagi dekat sini total, I tak bagi. I should know the formula lah. So if I give you total, degree of freedom for total and treatment, dan senang you tolak saja 15 tolak 13 dapat 12, right? Betul? Tapi kalau I tak bagi dalam final exam or test, you need to know the formula capital N minus K. Maksudnya the total observation, number of observation minus number of group, right? So 16 minus 4, it should be equal to 12, right? So then we need to calculate mean square. Mean square error means that the sum of square error divide by degree of freedom for error. So 153908.2 divided by 12. It should be equal to 12825.6833, right? So once you already get the value of mean square treatment and mean square error, so we can calculate for F value, which is the sum the mean square treatment divided by mean square error. So you should get 163246.7457 divided by 12825.6833. So you should get 12.728. 12.728. So it should be 12.7281 lah. Kita letak 3 ataupun 2 pun boleh lah. Ataupun 12.73 pun boleh. Right, so this is how you construct one-way Anova table lah. Right, ataupun one-way analysis of variance. Right, so any questions so far? Ada soalan tak berkenaan dengan ni?
Sir,
Ya.
yang SST tu memang kalau ada contoh 20 data semua kena masuk dalam tu lah.
Ya, 20 data. So, but we should not worry much because we have calculator kan. We just key in the data into calculator, apply the concept yang I ajar you sebelum ni, right? Untuk chapter 1 remember chapter 1. So this one kita mode, kita ambil 3 stat, and let's say kita ambil 1, right? So we just input 3229 masuk one by one lah, right? So I masukkan one by one, I tunjuk dekat you 2890. This is the first row. The next row 3300 and 2975 3150, and then this is the second row 2800 2900 2985, and then 3050. This is for third row, right? 2600 2700 2600, and the last one 2765, right? So you can recheck balik lah, right? So you go to shift 1 sum lah, number 3 ni. So you akan ambil number 1. So you akan dapat the value here kat sini. Yang atas ni sahajalah, right? Lepas tu you boleh divide by 4. You akan dapat 3. Should be 3. Mana tadi? Sepatutnya dapat ni kan? Kejap I check balik. Kenapa kita tak dapat? Dia dapat 138, right? So sepatutnya, ataupun I ada salah key in lah. So this one Oh yeah, correct lah. Benda yang sama kan? Right, correct. This is the first part. So, um, for this one ni, you kena calculate sendirilah. For the total of each row ni, you kena calculate sendiri. Right? Sebab susah nak detect dalam calculator kan? But we can have the total of y dot dot kita boleh dapat. Y dot dot kita boleh dapat, which is number 2 is equal to y dot dot. Right? Y dot dot. Right? So, yang dalam ni set satu yang SS treatment ni, you kena calculate one by one lah. Tak boleh nak buat apa. Ataupun you boleh key in another one dalam calculator. Senang untuk you dapatkan value. Okay?
Thank you, sir.
Alright. So, let's move to the hypothesis testing. Right? So, once you already have the table, then we move to the statement of hypothesis testing. So, first we need to put our hypothesis, null hypothesis, which is y mu1 equal to mu2 equal to mu3 and mu4. Sebab apa ada 4? Sebab kita ada 4 group. Right? If you have 5 group, means until mu5 lah. And then, this is a standard one. Alternative hypothesis, they always should be at least one pair of mean is differ. Ayat dia standard. Tak perlu ubah-ubah. At least one mean is differ. Right? At least one mean is different. So the second step is we should specify our alpha, which is, let's say dia kata nak alpha 0.05, and then our test statistics is equal to 12.73. So this one dapat daripada table ni. Let's say I copy Oops. Oh, dia mula hang lah. What happened ni? Kejap Oh. Oh, I think I see. Okay, so kejap. Saya letak kat bawah ni, senang kita nampak. Right. So, nampak dekat sini, F statistics, this is calculated, F calculated lah. F calculated. Right, so remember, this should be 12.373. So, decision rule, so kita kena tengok the F distribution. So, F distribution is a distribution skewed to the right. Right? Sebab kita ada 2 degree of freedom. So, kalau kita tengok table statistic, right, let me show you statistical table. Right, so this is table number 9 ni is about F distribution. So, you buka statistical table. Table number 9 is F distribution. So, you tengok the distribution yang dia bagi dekat sini is skewed to the right distribution. It's a F distribution lah. Dia sama macam last class kita masuk tengok chi-squared kan. Also a skewed to the right distribution. This is also skewed to the right distribution. So, it start from 0 until infinity. So, we're going to measure the rejection region. So, this is going to be a rejection region, and then this is our acceptance region, acceptance area. So we need to find the critical value that separate between acceptance region and this rejection region. So the critical value, this is a critical value, right? F alpha, degree of freedom 1 and degree of freedom number 2. So look at the F table. The one-way ANOVA table. So since we want to find statistic at significant level alpha 0.05, so it should be F 0.05. So kita akan measure one tail saja kat sini, right? So the degree of freedom, so we're going to take the treatment first, right? 3 as a degree of freedom number 1, and error should be the degree of freedom number 2. Right, so this is the critical value. So we look at the statistical table to find the value. So kita tengok statistical table, right? Statistical table, table number 9. Sebelum kita tengok table ni, kita baca dulu, right? You need to read and understand the value that the table give to us. So dekat sini dia kata the table give the value. Boleh nampak ah? Okay. Sekejap saya tutup ni. Okay, the table give the value F alpha, V1 and V2. Okay, sama macam konsep yang kita nak. Alpha, V1 and V2. So V1 is the degree of freedom number 1, V2 is degree of freedom number 2. So dekat sini, kalau kita tengok the first atas ni ada represent V1, degree of freedom number 1. Yang dekat bawah ni, V2, degree of freedom number 2. So kita tengok dalam ni ada banyak value. Apa value ni semua? So kita baca dulu. So for each pair of value V1 and V2 is tabulated for alpha 0.05, 0.025, 0.01, 0.001, and dia kata dekat sini the 0.05, 0.025 value being bracket. Kan? So the first one dekat sini represent, the first one yang atas sekali dia kata represent 0.05. And second one represent 0.025. The third one represent 0.01. The last one represent 0.001. Right? And dia kata dekat sini 0.025 is being bracket lah. So yang semua yang dalam bracket ni adalah alpha 0.025. Boleh faham? Right? So now kita tengok kita punya critical value yang kita nak is alpha 0.05. So alpha 0.05 is the first value yang dekat atas ni lah. Right? Yang dekat atas. Semua yang dekat atas ni is 0.05. So our degree of freedom is I tutup I punya note kah? Okay. Kita punya first degree of freedom is 3. So kita akan fokus kepada V3 dekat sini. V1 equal to 3 dekat sini, kolom ni. Semua value kat kolom ni kita akan fokus. So the next one is 12. V2 is equal to 12. So kita akan cari 12. 12 kat sini. So 3 dekat sini. So it should be equal to 3.49. 12, 3, V1 is equal to 3, V2 is equal to 12. So 3.49. So it should be 3.49. Right? So kita tengok balik dalam decision rule, if sini susah nak faham if F calculated is more than more than F alpha, degree of freedom 1 and degree of freedom 2, more than 3.49, right? Null hypothesis is rejected. So this is one way to make a decision rule. Another way is if F calculated lies under rejection region or rejection area, null hypothesis is rejected. So since kita tengok dekat sini decision kita, since F calculated is somewhere here, right, 12.73 lebih besar daripada 3.4, lies under rejection area, so we're going to reject null hypothesis. So the conclusion is we have enough evidence to indicate that there is a significant difference. Between the mean tensile strength of cement by using 4 mixing techniques lah. So ataupun kita boleh kata at least one pair of mean tensile strength is different, right? Boleh So ada soalan tak setakat ni? Very simple kan? So now let's look at this one. Example number 38. So basically you boleh tengok sendiri and you can understand by now because I already explained the basic concept. Right, you already tengok pun yang example 39, 38 you boleh faham dah. Right? So I think you boleh understand, boleh faham kot this one, right? 38, 39, you should understand lah. Very simple. I dah ajar sebelum ni konsep. You boleh tengok and understand. Right, so let's look at the SPSS output for one way Anova. So in SPSS, so they will give you one table. Right, this table sama macam yang kita calculate tadi lah. So the first one should be represent sum of square, right? So this is a sum. Dia kata kat sini between group. Basically the treatment lah, benda yang sama. Within group is the error. So you need to understand this is error. So the layout are same, right? So the first row is the treatment, the second row is error, the third row is total. Right, this is a sum of square. This is a degree of freedom, right? Degree of freedom senang saja. This is a k minus 1. This is capital N minus k. This is capital N minus 1. And the mean square error, just divide the sum of square divided by degree of freedom. Sum of square divided by degree of freedom dapat mean square error. The F value, mean square total treatment divided by mean square error, right? And the special of SPSS output, they will give you the p value, right? The last column, which is the p value, right? The p value concept dia tadi sama saja. So if p value less than alpha, which is if your alpha is 0.05, you just pick 0.05. Null hypothesis is rejected. Right, if more than 0.05, null hypothesis is accepted lah. So if dengar tadi macam I kata tadi mula-mula, kalau kita reject null hypothesis, if we reject null hypothesis, means that there is a significant difference, ataupun in other word we can say that there is at least one pair is different, right? One group is different, but we don't know which group is different. But we know overall, generally, there is a difference, but we don't know the specific group, which group is different. So we need to do a post hoc test. In SPSS, they will give you a post hoc test. So if you are using a Tukey test, they akan bagi tahu Tukey test lah. If you are using Bonferroni, they will tell you a Bonferroni. So this is the post hoc test. So dia akan bagi tahu dekat sini lah. to test apa yang dia guna. This is oops, tak boleh padam pula. Right. Ini dia guna LSD, right? Least square difference, right? Kita ada beberapa least square difference. Kita ada Tukey test, least significant difference, right? Right. So ini first kolom ni dia bagi tahu group yang kita ada lah, group A, group B and group C. And then the first cell row ni kat sini, the first row dekat sini, dia akan bagi comparison. Group A and group B, group A and group C. So if you have three group A, B and C, so how many comparison should you have? 3, choose 2. Right, remember STA 416. 3, choose 2 should have 3 comparison. Right, you should have 3 group comparison lah. Maksudnya A and B, A and C, B and C. So, ia ada 3. So, tapi kalau kita tengok dekat sini, dia ada banyak. Right? Apa maksud banyak ni? Maksudnya dia ada repeated lah. So, we have A and B and C. So, we have A and B dekat sini are repeated. A and B. B and A dekat sini sama dengan A and B. Kalau kita tengok jawapan dia sama lebih kurang. Right? Boleh faham ah? So, B and C. So, kita akan tengok B and C dekat sini. So, the mean difference is the mean of A minus mean of B. So, you will get mean difference. Right? Negative 5.6 ni, mean of A minus mean of C dapat negative 5.633. This is a standard error. Standard error is getting from a standard deviation divided by square root of n. Right? And this is the p-value. Right? So if the p-value is less than 0.05, the concept are same. If the p-value less than 0.05, so there is a difference between this group. Right? Kalau kita tengok dekat sini, the first group A and B. Right? Kita tengok the first group, A and B. So the p-value is 0.022. Right? 0.022 is less than 0.05 or more than 0.05. It's less than 0.05, right? So since the p-value for group A and B is less than 0.05, so we can conclude that there is a significant difference between mean tensor strength for group A and group B. Boleh Sama juga group A and C. So A and C, the p-value also less than 0.05. So we can say that there is a significant difference between A and C. Right? So another way to look out, let's say I did not give you the p-value. I tak bagi you p-value. I hide the p-value, for example. Right? In finite exam, listen carefully. This is very important. I will not repeat again. So if let's say in finite exam, I tak bagi this one. I tak bagi kosongkan. So I just give you the confidence interval. Dekat sini, I give you the confidence interval saja. I biar dekat sini. So if the confidence interval includes 0 in the interval range, so there is not significant. There is no difference. If the confidence interval contains 0 in the range, there is no difference. Means that the p-value should be more than 0.05. Boleh faham apa saya cakap? If the confidence interval includes 0 in the range, in its range, right? So the p-value should be more than 0.05. Right? Boleh faham? This is a general rule. Right? If the confidence interval does not contain 0 in dalam dia punya range, right? The p-value should be less than 0.05. Normally like that. Right? So kalau kita tengok dekat sini, the lower bound is negative 7.3 until negative 0.5. So dekat sini 0 is somewhere here, right? Tak masuk dalam range. So that's why the p-value should be less than 0.05. So kalau kita tengok dekat sini, right? Negative 4.6185 until 1.2953. So we can tell 0 somewhere tengah-tengah ni kan. So the p-value should be more than 0.05. So kita tengok sini, more than 0.05. So we can conclude there is no significant difference between B and C. Right? So I hope you understand that. I hope you get that. So now let's look at example number 40. Right. Actually semua sama saja. But kita tengok example number 40 dulu before we go to the next example. So example number 40, so they give you the data, right? We have the data, beginner, intermediate and advanced, right? So we have 3 groups here. So we have all the observation are here already, right? So the manager of a company wish to determine whether the mean times required to complete certain tasks differ for the 3 level of his trainee. So you select 5 trainees from each 3 group, right, and assign them with a task. Then you collect the time in days taken to complete the task was recorded in this table lah. So the data were analysed by using SPSS and the following result were produced. So dia bagi dekat kita the Anova table, right? So this is a significant value. The F value is hidden, right? Mean square error also hide. Degree of freedom semua hide. This one also hide. Right, so how to solve this one? Selalunya masa tak panjang dalam final exam, you ada 2 jam saja. So I will not give you this exercise lah. Soalan-soalan yang panjang macam ni tak akan keluar lah. Right, ataupun kalau I kejam, I keluarkan soalan macam ni lah. Mungkin tengoklah tahap kekejaman I macam mana kan. I good mood, I bagi soalan senang-senang. Right, so between groups, right, saya nampak dekat sini within group. So kita kena selesaikan masalah yang simple dulu kan. So yang simple adalah this one. This one very simple, right? So let's find R. Oops. R is the degree of freedom for treatment. So degree of freedom for treatment is K minus 1. Means the number of group minus 1 should be equal to 3 minus 1 equal to 2. Right? And then we already get this. Ni dah dapat 2. Ataupun kita buat satu lagi table lah. Senang nak nampak. Kalau tidak susah. Dia dah tulis huruf dalam tu. Right? Let's say this is satu lagi kolom. Right? This is source of variation. This is sum of square. Degree of freedom. Mean square. F. So this is treatment, error, total treatment. This is 11.6, 5.067. Then that's all. Itu saja yang kita ada. So kita input the value lah. This is K minus 1 is equal to 2. Error kita boleh carilah. Ataupun this one the total should be equal to 15 kan. 15 minus K is equal to 3, should be equal to 12. Right? And 15 minus 1 is equal to 14. Right? So 12 tambah 2 equal to 14. Sama kan? And then for error dekat sini kita boleh cari kan? 11.6 divided by 12. So it should be equal to 0.9667 lah. Kita ambil 3 decimal point. So dia pakai 3, kita bagi 3. And then the last one kita boleh cari kan? F value 5.067 divided by 0.9667 should be equal to 5.2415. Boleh lah bagi panjang sikit. Right. So then sini dengan sini. Yang paling senang kita boleh cari kat sini lah. Right. Sepatutnya SS divided by degree of freedom dapat MS. Right. SS divided by degree of freedom dapat MS. So untuk dapat MS, dapat SS, so MS multiply with DF. Right. So it should be 5.067 multiply with 2. Right. Should be 5.067 multiply with 2 equal to 10.134. Right. So the total ditambahlah 10.134 plus 11.6 should be equal to 21.734. Then complete. Right. So next step we can do the hypothesis testing. Right. Null hypothesis mu1 equal to mu2 equal to mu3 ataupun kalau kita letak mu1 equal to mu2 mu3 tak menjawab soalan sangat kan. So the best way to put is mu beginner equal to mu intermediate equal to mu advanced. Right. Null alternative hypothesis at least one pair is differ. Right. So let's say dia kata dekat soalan B ni dia kata alpha is 0.05. Right. So there is two method. You kena baca soalan, right? Dia kata dekat sini based on the p value. So don't waste your time to calculate based on critical region. So kalau dia kata soalan ni based on p value, you buat critical region based on f value ni, you dapat kosong marks. Baca soalan betul-betul lah based on the p value. So dekat sini dia bagi p value is 0.0223. So the p okay. The p value equal to 0.023. And then decision rule. If p value less than alpha, which is 0.05, null hypothesis is rejected. So our decision here, since the p value is less than 0.05, which is our alpha, null hypothesis is rejected. And conclusion is at least one kita ikut soalan lah. One group, right? One group is different lah. So which group different, we don't know. So we need to do a post hoc test, right? Okay. So sama juga untuk example number 41, cari dia punya value, right? And then state the null hypothesis and alternative hypothesis. Dia dah bagi dekat sini. And then dia kata sini, you kena baca soalan betul-betul lah. This one dia kata using f-test. Using f-test. So if you using f-test, you kena buat decision rule based on f-test lah. You kena calculate the critical region, right? Our critical region should be dekat sini. This is a rejection area. Let's say kita dah cari dekat sini. This is berapa ni? Q adalah 4. F adalah T 1.5861. So Dekat sini, F, let's say 5% kan? 0.05, 4 and 102. So, now, 4 and 102. So, kita tengok statistical table. 4 dekat sini. 1, 2, 3, 4. 102, kita turun bawah. 102, where is 102? We don't have 102 here. Right? We don't have 102 here kan? We have only 60, 120, infinity. So what we can do is, we can take the average of 102, 60 and 120, right? So, ataupun, sekejap right? So, kalau kita ambil average, 60 and 120, kita akan dapat dalam 90. Tapi selalunya dalam final exam, kita akan avoid soalan macam ni lah. Right? So, we will give you the value yang ada dalam table saja. So, what we can do is, macam ni lah. Kita boleh ambil dua value, 60 and 120 divide by 2. So, the nearest point kan is 690 kan. So, kita dapat 2.49. Right? So, compare with the calculated F value. So, kalau dia duduk dalam acceptance region, we do not reject null hypothesis. If dia duduk dalam rejection region, then we reject null hypothesis. So, selalunya kalau soalan macam ni, I bagi dekat you P value, you already know that this is not significant kan? Because the P value is more than 0.05. So, dia nak tengok you faham tak buat macam ni. Dapat, mesti soalan, jawapan mesti sama. Tak boleh lain daripada P value punya result. Okay? So, I think that's all for one way Anova. And basically, we finish chapter number 4. Next class, we will look into chapter number 5. After chapter number 5, we will have a test number 1. Right? Okay, ada soalan tak before we end our session? If you don't have any question, then I think that's all. Thank you very much.